that's the end. It just keeps returning. Just, yeah. Get rid of it, would you?
It's lunch.
Is it?
No.
Or is it breakfast? My breakfast this morning was a Kit Kat. Similar, yes. Okay, next one now. 16. So this diagram shows a steel tank. It's made of metal sheets, 3 millimeters thick. The tank is open at the top. Find the mass of the tank. So I have to draw this very carefully. It says it's made from 3 millimeter sheets. So what they mean is it's like you have a sheet of steel and it's 3 millimeters thick. Okay, so if I was to put that together, I would have to do it like this. That's the first sheet. So that's not very clear. But I don't think it matters too much. But I think if we're trying to make this realistic, we should put the base sheet underneath it so that it can rest on top of it, instead of sticking it to the side. So they're not stuck together just to help you visualize it. And then of course there's one at the back which as well will be sitting on the top, just like the one in the front. And then likewise it sits on the top. And that one will be at the back as well, so I won't draw that in. So there's actually 1, 2, 3, 4, 5. There's none on top. It says it's open at top. So the first one is we want the mass. So before we can find the mass, we need to find the volume. Now, how wide is this steel tank? It's 1.5. So here to here is 1.5. And how long is it? 2.5. And then how big is this little piece here? Well, we're told that it is 3 millimeters. So the volume for the base piece would equal 1.5 times 2.5 times 3 times 10 to the minus 3 for millimeters. So I would get 0.01125 meters cubed for the base. Now, but I don't know if these are the same. They might not be. So I have to look at the lengths. I don't think they are. We're told that it's 75 meters high. 75 centimeters high. But we have to take away the piece at the bottom. We can't include that. So it's not quite 75. It's actually 75 minus 3 millimeters. So that is 74.997. Now the thickness is still 3 millimeters.
75 centimeter minus 3 millimeters.
Yeah. Because if you look at the diagram, we're told that it's 75 centimeters high.
No. It should be 74.7 centimeters.
Oh, sorry. Oh, sorry. Got the number wrong. 0.75 meters minus. So it is 0.747 meters cubed. Okay, that's the height. And the thickness is still 3 millimeters. And then how long is it? 2.5. So the volume for the side, now I'm going to multiply this by 2 because there's 2 of them. 2 times 0.747 times 2.5 times times 3 millimeters, 10 to the minus 3. So that is 0.011205 meter cubed. Now we haven't done the front and the back yet. So the volume of the front and back would equal. So notice how this is the same height, 0.747, and the thickness is 3 millimeters. So we haven't got just the width here. How big would that be? Well, it'd be 1.5 minus 3 millimeters minus 3 millimeters. So 1.5 minus 6 millimeters. So that is 1.494 meters. So we do 1.494 multiply 3 millimeters multiply 0.747 meters, and there's 2 of them, so multiply by 2. So the front and back will be 0.00669,108. So now adding all of those together to get the total volume, at long last the volume for the whole thing will be 0.02915 meters cubed. Now we can finally get the mass. Yes. Front and back, F and B. So mass is density by volume. So now I multiply this by my density, which is 7,900. And we get 230.29, so 230 kilograms. Quite a long question for only 3 marks, I think. But anyways, 3 marks it is. Now, it is now half full of water. So look, just be careful. We have to get the volume of the inside of the tank and then multiply by a half to get the volume of the water. So the volume inside the tank, what number do I use first? 1.494 times, what's the height? 0.747. Now, how long is it? Well, the length would be 2.5 minus 6 millimeters. And then divide by 2. So I got the volume of the water will equal 1.39 meters cubed. So then the mass of the water would equal density times volume. So 1392 kilograms. But he wants the total mass. So that would be 1392 plus 230, which would equal 162. What's wrong?
Which one's the volume of the inside?
I have a mistake here, sorry. I'll go back in time. Don't worry, I'll write it again. Let me do the calculation again. So the volume inside the tank. Let's do that again. And by the way, I'm sorry, it's not water, it's oil. So the density of oil is 910. Okay, so it's 1.494 multiply 0.747 multiply 2.5 minus 6 millimeters. Now, does that make sense, MB? And then I divide that by 2 because it's half full. So the volume of the oil is 1.39 meters cubed. Now, the mass is the density by the volume, and density of oil is 910. So we get, yeah, it should be different because I used the wrong number last time. 1266 kilograms of oil. What was the mass of the tank at the beginning? 230. Close enough. So the total mass unfortunately, the question said show that the total mass is 1,511, whereas mine is 1,496.
Maybe because the way they are put together.
I believe so. I actually think when I did this, can you look up, guys? I actually think when I did this with the intake 1 students, I actually, instead of putting the walls on the top of the tank, I think clicked them onto the side. Now, if you click the walls onto the side, does that make the volume on the inside bigger or smaller? Bigger, which makes the mass of the oil bigger as well. So I think not my mistake, because he didn't give me a diagram to show me how to put this tank together. I felt that if you were building a steel tank, you should put the walls on the base. But maybe not. Maybe it's better to click them onto the sides. But this is an explanation why my answer is a little short. I should have gotten 1511. Instead, I got, what was it? 1496. So what I'll do is, I won't upload this video. Well, I'll leave the other video up there, which is from the other students, because I think I got the right answer when I did it with them. I must have put the walls on the side. Okay? But we can still finish it. The last part now. Actually, I'll put up both videos. You can see it both ways. How much energy do you need to increase it from 20 to 30? So what formula is that? Delta Q equals M C delta T plus, now what's the mass of the oil? It should have been 1281 instead of 1266. C delta T. Quite a large number. (94 megajoules). Okay. What? No.
Isn't it oil?
For oil, 2400's oil, yeah. So I'll maybe make a note at the end. Note, I put my tank together like this, whereas it should have been like this. I guess actually when I think about it, this is more stable because you can put a bolt in here, you can put a bolt in here. Well, whereas this one you put a bolt up here, put a bolt up here. I don't know.
Yeah, the right way is more stable.
This one would be better, will it? Anyways, no big deal. I mean, if you did that in the exam, the question is 8 marks. I might even still give you the full 8 out of 8 because I shouldn't take a mark away from you just because you constructed your tank in a different way. So I don't really see this as being a big deal. Okay.